about the Automatiko project. Today I would like to introduce you to a feature that is around the fault tolerance area, and that is to easily and automatically recover from crashes of your services. This is based on the concept of transaction log. So now you can enable the transaction log for your Automatiko services, and that will record all execution done as part of the transaction and be able to recover in case of crash. So let me introduce you to the demonstration for today. So we're going to use the Red Hat OpenShift as our Kubernetes environment, so we can easily show that as soon as the pod crashes, it is automatically restarted, and at that time it is automatically recovering all the in-flight transaction that was not successfully committed. So let me introduce you to the project. So we have the Automatiko subprocess, and there we have two main processes or workflows. Here, first one is based on the script that simply wait on either say hello or pause, and then depending on the part you're in can take a bit more time than usual. And at that time, if the crash happens, it will be automatically able to recover from the particular step. And the other example that is a little bit more advanced is to showcase the same behavior, but within the scope of sub-processes. So if we have the main or top level process, we have the add items that is called to this workflow definition, and then acceptance is called here. So we have like a hierarchy of 3 levels that will interact with our process. And let's take a look at our service. So we have it deployed. This application, we can take a look at the deployment. Deployment, and there we go. So everything is controlled by the environment variables. So by default, and it is right now, the transaction log is disabled, set to false, but we already have the configuration for the folder because we enable as part of the demonstration. And it uses as well the persistent volume to keep the data outside of the pod so it can survive the restarts. So with that in mind, let's take a look. This is our service definition. So we have the APIs, so we have the orders and scripts. We'll start using the scripts, but let's take a look at the process management. So we have the information that there are no instances. So keep in mind that we are right now running inside the non-enabled transaction log. So let me just grab the pod because I'm going to kill it. So we have the application there. So let's just go back here and we just get the delete pod and just specify that. So we are ready here. Let's just start an instance of the script. That will take a bit, and we immediately kill it. As you can see, it just went down and did not finish in time. So if we look at the pods, a new one is running, and there we go. So it already restarted, so OpenShift brought it up. But the thing is that we actually lost our request, meaning that the service that was invoked failed in between, and that simply because it crashed, it did not succeed, it did not save it, so we kind of lost the request from the user. So now let's do the same, but enable the transaction log. So the only thing we need to do is go to the environment, set it to true, and save it. And once that is saved, it should be in the pod. So we have a new pod in the container creation. Here, so let's just copy the name of it. We do exact same exercise. Just prepare this. Alright. Okay, up and running, great. So we do exactly the same thing. So here is and we kill it again, killed. We look at the pods, a new one is already running. And the interesting part is here that you can see that it did the transaction recovery as part of the startup, successfully recovered that instance, And if we now go to our process management, you can already see just the route, refresh it. Come on. And there we go, the instance is already there. So we were able to successfully recover at the say hello, because this was the long running task, and then it immediately went there, so we can then grab this information. Great. And then in meantime I can show you as well another feature of 014 is that if we just take the actually ID that was successfully recovered and just use that to get it from the API. If we specify the metadata that we want to look, we get the information, and it is the new features as well is the links that are attached to the metadata that will give us the information about the next task that are waiting for the user who is making the request. So that is a simplification for users to not have to go to get the task and so on, because we can then easily grab this information to, for instance, view the form of the task. Just put the route like this, and there we go. There we have a complete report. But let me just illustrate another thing, is that it's not just for the instances that were not yet created, but the instances that are already created, and if they fail inside the execution, they will be recovered from the time as well, and what is important is the data will be kept as well. So let me prepare another command to kill the pod, and this time right, yes, okay, so we're ready here. So what we are going to do, we're going to use our task, and we will say hello, and again this one is going to a task called pause, if you can see here, and this will take a bit of time before moving to the signal node. So if I just click on this and do like this, it should kill it as well. Now we go back here, you can see the pod was killed. Let's look at the new pod being created, and we look at the logs, and again it, as you can see, it recovered it again. And now if we go back to our process management, right, come on, process management UI. Oh, now it showed some network glitch. Alright, so we have in one instance, and we can look here. As you can see, it's already in the signal, and it has the data preserved as well. So that gives you the direct information that even though it failed, it was capable of recovering, so there is no loss in user requests, because every transaction that is ongoing on in flight at the time of the crash, it is automatically recovered of the on the next start. Alright, so let's take a look at the same thing but for the sub-process. So let me just grab this. So for this one, let's try it, and we specify John as the approver, and just put 1, 2, 3, 4, 5 as the order number. Everything else is not that important. So let's do exact same exercise. Let's just copy the pod name, so we can actually kill it as well. So this time, if we start that instance, what it should be doing is that it goes to the order process. This is the starting point. It just has a wait state here. Oh, actually this one actually goes straight through to the next one, so it creates the sub process, and then the sub process has the calculate total. That is a long running, or it might be a long running. So what we wanted to illustrate here is pretty much the same disaster recovery or the fault tolerance, is that as soon as it crashed, you can already see that there are multiple parts of the instance. That means that it had actually have to recover multiple instances. So let's do that again. We're ready here, so we're running and then killing the pod. Come on, fast enough. No, it is not fast enough. So it actually killed it after it was created, but it's not a big deal, because let's see here, so the recovery is not in place yet because it succeeded. So if we look here, but don't worry, we'll use another use case, not just wait for it to be running. Okay, so now we should have one instance here as well. The network is not that fast. Okay, as you can see, so we can go back here. We look at our instance. So we have the data, we have sub instances, and you can see it's waiting here. So now if I just complete this one, it goes to the accept, which has another wait. So let me just again prepare the command. Okay, so the command is prepared, but then let's grab the form. So we just do it like this. We say it's 1, 3, 4, 5. That's the request, and just search for it. So here we have our form link. Before we do this, I'll just open a new tab. Just grab this, copy the form link, another useful feature because you can already do this like that. Alright, so we have the verify order 1, 2, 3, 4, 5. Alright, so we created, prepared, and then let me just do this. I just do this. Alright, it killed it. So you can see the pod is there, so it's restarting. We are in the container creating, and then we can look at the logs. Hopefully as soon as it starts we get the information that it's recovering. As you can see, it's recovering the order items 1. About to wait before moving on. There we have successfully recovered, and if we look at our instance, this one, you can see it has the sub process. You can just expand that. There we have it moved already there because we completed, even though it fell in between, it has the instance there too. So this one executed and we are waiting there. So as you can see, the transaction recovery works automatically on the restarts of your pod and brings in to the state where it was supposed to be, including the activities that were invoked, meaning that it will not perform again the same activities that were already completed, but will start off the instance at which the instance was when the crash happened, meaning that it happened at this place, so it actually executed this once again, but nothing before that task. So that is the least the repetition, but it gives us the guarantee that it will not affect and it will not negatively affect the end users who sends the request to the service, because they will be automatically recovered. Obviously the user will get an error as part if it was a sync operation and was waiting for the reply, but as soon as the service is back up, it will recover it and continue with the information and execution of the required stuff. So with that, I would like to thank you very much for listening to this a bit longer video than usual, and yeah, stay tuned for the next ones. Thank you.